Picture this. It's the summer of 2025, and astronomers spot a faint speck of light moving through our solar system. Now, this was no ordinary comet. No, this was a visitor from another star, a relic from the dawn of the galaxy itself. And its behavior? It was so strange, so unnatural. It sparked a debate that literally reached for the stars. This is the incredible story of the cosmic mystery known as 3I/Atlas. So, it all kicked off here, on a dark night in Chile. A network of robotic telescopes called Atlas, which are usually busy looking for asteroids that might threaten Earth, picked up this very faint point of light. And right away, they knew. Just by looking at its path, they could tell this thing wasn't one of ours. It was just passing through. This visitor was given the name 3I/Atlas. Now, that 3I part is super important. It means it's only the third interstellar object humanity has ever confirmed. It came after the mysterious Oumuamua and the much more normal-looking comet Borisov. But as we'd soon find out, this new traveler was totally different from both of them. So what actually makes something interstellar? Well, it really all comes down to its trajectory. An interstellar object is on what we call a hyperbolic path. Basically, it's moving so ridiculously fast that our sun's gravity just can't grab onto it and pull it into an orbit. It's like a cosmic tourist on a one-way trip through our neighborhood, and it's never coming back. Let's just visualize that for a second. On one hand, you've got the comets from right here in our own solar system. They're stuck in these looping, elliptical orbits captured by the sun's gravity. They're destined to come back again and again. But then you have these interstellar objects like 3I/Atlas. They are on a pure escape trajectory. They just scream through the system and then head right back out into the deep, dark void. And when I say fast, I mean fast. 3ATLS was clocked at a mind-boggling 58 kilometers per second. This speed wasn't just impressive, it was way faster than the other two interstellar visitors we'd seen. This incredible velocity was the final definitive proof. This thing came from a long, long way away. You know, by tracing its path backward in time, astronomers figured out something truly profound. 3I/Atlas didn't just come from another star system, it came from what's known as the Milky Way's thick disk, a population of really ancient stars. This means the comet itself could be up to 14 billion years old. Think about that. It might just be the oldest comet we have ever laid eyes on, a true piece of our galaxy's youth. But this is where the story gets really weird. As astronomers pointed our most powerful telescopes at this ancient traveler, they realized it wasn't behaving like any comet they'd ever seen before. A whole trail of bizarre clues started to pop up that just didn't make any sense. Okay, so the first big puzzle was its path. I mean, out of all the infinite directions it could have come from, its orbit was almost perfectly lined up with the plane that our own planets travel on, the ecliptic. So, just how strange is that? Well, the odds of some random visitor from deep space just happening to have that specific alignment are tiny, like 0.2%. It's not impossible, sure, but it was definitely weird enough to make everyone sit up and take notice. Was this just a wild cosmic coincidence? All right, the next clue came from what it was made of. As the comet got closer to the sun and started to heat up, the gases it was releasing were, well, they were unlike anything we expected. This wasn't just a slightly different recipe. It was like it came from a completely alien cookbook. And the James Webb Space Telescope gave us this incredible piece of evidence. Just look at the ratio of carbon dioxide to water. In our own comets, there's a pretty predictable pattern. But in 3I/Atlas, the CO2 levels were just through the roof, some of the highest ever recorded in any comet, period. Something was fundamentally different about where this thing came from. Then came the metal mystery. Telescopes picked up a ton of nickel vapor in the cloud of gas around the comet. Now, normally where you find nickel, you find iron. They're like cosmic partners in crime. But here, plenty of nickel, but the iron was nowhere to be found. It's a chemical signature that still has scientists scratching their heads. And the final piece of this chemical puzzle was what wasn't there. You know, comets are usually packed with simple carbon-based molecules. But 3I/Atlas was mysteriously missing them. So much so that one study called it one of the most carbon chain depleted comets ever known. So, with this trail of improbable clues piling up, humanity basically threw all of its scientific might at this thing. The world's most powerful telescopes, from here on the ground to way out in orbit, all turned their gaze to this cosmic wanderer to try and crack the case.
The Hubble Space Telescope gave us our first really sharp look. Its powerful vision sliced right through that hazy cloud of gas and dust, and it let astronomers figure out just how big, or really how small, the solid nucleus at its heart was. It was less than 5.6 kilometers, or 3.5 miles across, a tiny little core to be causing all this cosmic drama.
And of course, the James Webb Space Telescope delivered even more detail. It didn't just see that the chemistry was weird, it measured the output with unbelievable precision. Every single second, the comet was spewing out about 129 kilograms of CO2, but only 6.6 kilograms of water. This kind of hard data grounded the whole mystery in undeniable facts.
And in a moment of just perfect cosmic timing, the comet's path took it pretty close to Mars. This was amazing because it allowed a whole international fleet of spacecraft already orbiting the red planet, from NASA, the European Space Agency, and China, to get a totally unique look at it. It was a global effort to understand this thing from every possible angle.
So, with all this data flooding in, two very different ideas started to take shape. One was rooted in everything we know about how the universe works, and the other dared to ask a much, much more extraordinary question. Was this just a very strange comet, or could it possibly be something else entirely? And this led to a major split in thinking. On one side, you had astrophysicist Avi Loeb, who suggested that when you add up all the anomalies, the improbable path, the strange chemistry, maybe they could be interpreted as signs of technology, a probe. But on the other side, you had the overwhelming scientific consensus, which argued that, yeah, every feature is unusual, but it could all be explained naturally for a comet that was born in a totally different alien environment than our own. And that consensus is really, really firm. As NASA's Amit Kshatriya put it so clearly, this object is a comet. Every single observation is consistent with a natural object. The anomalies aren't proof of technology, they're actually clues about its origin. For instance, that sky-high CO2, it probably means it formed in an extremely cold part of its home star system, much colder than where our comets formed. And that lack of carbon chains? Well, that could be the result of billions of years of damage from cosmic rays as it drifted all alone through deep space. It's not alien, it's just ancient and incredibly well-traveled. Look, the story of 3I/Atlas isn't just about one strange rock. Its discovery, and the ones that came before it, they signal this huge shift in how we see our galaxy. We are just starting to realize that there's traffic out there on a vast interstellar highway. And what's so fascinating is just how different each of our three visitors has been. Oumuamua was just enigmatic, with no coma. Borisov looked like a pretty typical comet, and then 3I Atlas was ancient, super fast, and chemically bizarre. This incredible diversity is proof that by studying these objects, we're getting a sneak peek into the huge variety of planetary systems that are out there. And we are about to open the floodgates. The new Vera Rubin Observatory is a complete game changer. Instead of just stumbling upon one of these things every few years, it could potentially discover up to 70 per year. We are moving from an era of rare one-off curiosities to an era of real statistics. So, that's where we are. 3I Atlas has shown us that our galaxy isn't just a bunch of isolated star systems, but this dynamic, connected ecosystem that's constantly swapping material. It was a messenger from a time and place we can barely even imagine. Its mysteries remind us that we're standing at the dawn of a new age of discovery, with a sky full of travelers just waiting to be found. And that leaves us with one thrilling question. What will the next one teach us?